Hi, everybody. Welcome to another Chats with Children. I hope you're safe and well. Today's Chats with Children is all about the challenges around detecting defects in medical device packaging and using airborne ultrasound technology to help with those particular challenges. And to help me discuss that today, I'm delighted to be joined by Rob Zecchin from PTI Packaging Technology Inspections. And Rob actually is one
Hey,
of the very
Roswell.
first. Hi, Rob. Rob is actually one of the very first people I did a live video interview with and a live
Yeah,
demo at Interfex way back in 2019. It seems like a lifetime ago since
yeah, it does.
COVID. Anyway, so
It
Rob,
does.
it's lovely to see you. How are you?
Good, good. I'm well. I'm well. Yeah, we're doing good here at PTI. It's the summertime. We're just, enjoying summertime activities and, just cranking away here.
Brilliant. Well, it looks like you're in the office actually today, aren't you?
Yes, yeah. It's this is our new demo area, yeah, it's lovely. It's a lovely space to work and collaborate. So we really enjoy it.
Brilliant. Okay, so before we
Yeah.
start talking about the challenges around detecting defects in medical device packaging, would you mind giving people a quick overview of your own background and a little bit about PTI as well for those not familiar with the company?
Yeah, sure. So PTI, we specialize in what's called container closure integrity testing. It's an important part of a quality aspect for medical device and pharma and food as well, where we're looking at primarily leak detection. But also in today's technology, I'm going to talk about not only leak detection, but we're looking here at actual seal quality too, which is a little bit different than a breach in your container or package. Yeah, I've been with PTI in our sales role for a little bit over 3 years now. Yeah, it's been a great learning experience. Yeah, I enjoy the industry. It's really an exciting industry. It's, especially in the last year, with everything going on globally, and the importance of, virus, vaccines and that sort of thing. It's really been a really exciting time here.
Brilliant. Okay, well, let's talk about medical device packaging. I mean, you already touched on it a little bit in that little intro. So what are some of the problems you can have with medical device packaging?
Yeah, I mean, so, you've got your medical device here and inside, and you have your sterile barrier here, which is usually, well, in this case, it's a flexible package. And it's then you have a seal here, which basically is bonded together to ensure that the device remains sterile. And so that the primary purpose, obviously, is a sterile barrier. So you don't want any type of microorganisms going in here and then getting inside and breaching this package. So that's one of the challenges. The other in medical device packaging is, it doesn't have to do with the actual sterile barrier, but it's how easy this package is to open. So, if you imagine you're in the operating room, right, you don't want to be fumbling around with a medical device where you're trying to kind of pull it apart or, rip it off with your teeth or anything like that. It's got to open really easily. The nurse presents it to the surgeon, it opens up and you could easily take it out. You don't want to, you kind of pull it apart and then you've got stuff flying open. You don't want it to be open, obviously, as you're getting ready to perform the procedure. So that's obviously important too as well. So those are two of the primary factors really that go into this type of packaging.
But listening to that seems a bit contradictory in some respects, because you've got one where you're saying you want to keep it perfectly sealed and keep it sterile. Then on the other hand, you're saying you want to make it really easy to open.
Yeah,
And so,
yeah.
it sounds contradictory to be able to do both those things easily.
Yeah. There's an optimum sealing like temperature and parameter and how well those layers are bonded together in this. And so you could have something that has a great bond, right? It's perfect. However, it does have a small channel leak that doesn't necessarily affect the actual peel strength and the overall adhesion of the entire seal that you're taking into account. But it's not sterile, so that's not good. And conversely, you could have something that's actually sterile, right? There's no breach, there's no channel in here where you could get outside organisms. but the bonds are not, it's not well bonded together. And sometimes you could find out about that afterwards, right? After the product is left, your manufacturing facility, if it's, taking an airplane ride or, going over the Eisenhower Pass, it's going to inflate, right? Like, when you go up in an airplane, obviously you have a bag of chips or, I'm sure as you guys call them, crisps, and it kind of, starts to inflate. It could stress those seals. So if you have something that's really weakly bonded, then your breach occurs post shipment, which is not good. And then it arrives, obviously, into the operating room or the end user, and it's already breached. So that's not good either. And so it's, you could kind of have both situations. Yep.
And how do you test for these then?
So what we do is we're using our airborne ultrasound here, which is essentially we're pulsing air. So we're using sound waves, and we're pulsing air within the seal area. You've got a transmitter on one side, a receiver on another, and it kind of operates the best way to, the simple analogy is it's like a double pane and a single pane of the window. So like if you have a single pane, right, you're in an office building, a truck rumbles by, you could hear the noise coming from that truck. If you have a double pane of glass, you have that air gap between there, and that sound is then deadened. You don't hear the truck as much. And that's because the sound doesn't travel well through air. So you get a loss in the actual signal. And that's what we're looking at, the same principle we're looking at here, where we're looking at any loss in signal. And that's typically, if you have an air gap, when those layers are not bonded well together, you'll have like an air pocket like that and a loss in signal. And that's what we're detecting with the seal scan.
Cool. And I understand you've got Seal Scan right there at the moment so that you can demo it.
Yeah, I do. Yep. So we've got a device package here. I'll go ahead and hit the start button. And what you're going to see here on the HMI here, or the laptop, is we're looking at here is one of those channel defects that I was talking about. So if you want to just come in a little closer, maybe we could get a little better view of that. And so you could see here, there's a breach in the seal. The way this works is there's a color code here you can notice, and there's also data here. So that's the other important thing. A lot of other test methods that are out there don't actually give you data. They're more of a visual check.
Right. Okay.
And so this is actually giving you test data as well as a visual too, as well. So you have here, this green area here that means that the seal's well bonded, but in the red area here, red being bad, that area there's a breach. There's a channel leak right through the seal there. And so that's how we could detect those channel leaks. Additionally, what you would see, we've got this color coding system here where a green is basically a normal signal. So that's what a normal pouch would look like. Anything that is yellow or red that would come up in here is a degradation of the sound signal. So that means you've got a problem. You've got an air loss of signal, an air pocket. And then it's also color coded with a blue, which means you're getting more signal transmission, which could mean a breach, or when you overheat a seal, it crystallizes the material. So then the sound actually propagates easier through there because it's more of a solid. And then you've got some data here. And one of the, it shows you like the average signal, the minimum signal, standard deviation, and that's a key one. So we look at when you're talking now just seal quality, right? Not just a breach. You want to look at the data that you're getting across your seal. And you want that standard deviation to be fairly low. That means you've got an even seal. Once you start to see that standard deviation increase, above like a value of 2, and that depends on the material, but in this case, above a value of 2, that's when you know you've got some issues. You've got uneven areas of your seal, and you don't have even sealing and equal bonding across the seal. And what you could actually do with that data is, another test that's used is as we talked before, the peel strength test. You could then actually correlate that data here with your peel strength. So if you say, okay, we'll open up a pouch, we've got the optimum, in terms of how well bonded this is. And you could get those values here and say, okay, this is a good pouch. We like this peel strength. go ahead, pull it off the line, test it. This is the values we expect to get from that. And then anything else, you know, if it falls out of that optimal range, you would know that there's an issue then, and you'd have to take a look at your sealing process again to kind of correct for that. And so it's not only a tool to look at where you have defects, but it's also actually could be used as a process characterization tool as well.
Right. Okay. And what are the primary applications of this technology, and what markets and industries?
So it's primary in the medical packaging industry, but we also do use it in food as well. So we do have applications where it's used in food packaging. You know, I'll give you an example is if you've seen the tuna fish pouches or pet food, they've got now these retort, you know, single packet use pouches. That's a very popular application for it. And yeah, so those are the two primary areas it's used in.
Right, and you mentioned some of the areas, some defects that they measure. So what other sort of defects in packaging can the technology detect?
So you could detect channel leaks, any kind of voids, weakly bonded seals. You could detect sometimes pinholes if they're big enough, which are usually not a typical issue, but you could breaches or cuts, which could be foldovers. So even in a medical package, they actually look at that. They actually look at the actual cosmetic of the seal. Sometimes that's important, just how it looks, right? It could be an okay seal, but if it's folded over or wrinkled, it's no good. And that's something that this could also pick up as well.
Right. Okay. And you know, what are the benefits? Why is this technology particularly important in medical devices?
So it's important because, you know, it's one of the few technologies where it's non-destructive. So that's a key. There's some other methods of dye ingress or bubble leak test. Those are all destructive methods when you're looking at a medical device or testing it for sterility. So it's a non-destructive test. And it's one of the few that could also do Tyvek as well. So Tyvek is a porous leaking, barrier. And so traditional things like vacuum decay or mass extraction or those types of things, where you're trying to take air out of a package, those won't work because it's already leaking. So you can't really do anything. So with this though, with those Tyvek seals and those Tyvek flexible packages, this is one of the few technologies that you could actually inspect those seals and do it non-destructively too.
Right.
Well,
Okay.
it's important. Yeah.
And in terms of the manufacturing environments, which sort of manufacturing or what types of manufacturing environments can you use the technology in?
Yeah, so this is an offline system, so you could use this in a packaging lab. You could also use it in a manufacturing setting where you're just pulling packages off and running them through to test them. You know, in the example here, you saw that sensor was going back and forth, creating that image by running multiple times across the package. But you could actually just do it in a single pass too as well, where it's just doing one single pass. And so for that reason, you could use it in an inline application too, where if your packages are going down the line, you're just running across. You could incorporate it, like, for example, in a band sealer. And then you would go ahead and scan a single line, and you'd be able to pick up things like this channel defect. So it's for offline and inline too as well. Right.
So basically you're saying an automated process where you can actually see a whole batch, then you can check everything in one go.
Yep, exactly. Yep. Mm-hmm.
Right. Fantastic. So if people want to get more information, where can they get more information about the technology and also about other ways that they can sort of detect leaks and other damage to medical device packaging?
Yeah. So, I mean, I would say our website, ptiusa.com. We are going to be in 2 weeks, August 10th to the 12th at the MD&M and Westpac show out in Anaheim. If you are out in the area, please obviously come visit us. We'll have this equipment with us, and we could have a discussion and do a little bit more of an in-depth demo for you. And those are probably those are the two best ways right now to come see it. Yeah.
All right, Rob. Well, I wish I was there myself, but obviously traveling from the UK to the US is not permitted at the moment. Otherwise, I'd love to have done another video with you live. So, well, thank you very much for sharing that information. It's really interesting to learn more about the technology. You know,
Yeah.
as I said, it always amazing when I have these conversations with you guys talking about leak detection. You know, there's so much physics involved in all of this as well, isn't it? So it's funny talking about life science products, but you're always talking about physics and using that technology in terms of detecting the problems within life science and chemistry and biological products. But thank you very much for sharing it.
Absolutely.
If people would like to know more, please check out the website. The link will be above the video. Leave any questions for Rob below the video. And also, as Rob said, if you're in Anaheim in August and you're able to pop over to the show, the link for the event actually, because I know you can actually get a free exhibition pass using PTI's link, because I've tried it myself. You can click on that and you'll be able to get a free pass to the exhibition. The link for that will be there as well. So you can see them live if you're there. You can check out them virtually online, and you can leave questions for Rob. So there's lots of ways to find out more about the technology. So Rob, lovely to see you again, my friend. I look forward to hopefully catching with you face to face in the not too distant future, hopefully.
I hope so too. I hope so too. Yeah, that'd be great.
It would be great. Well, lovely to see you. Thank you very much for that. And thank you all for watching. As I said, if you'd like to know more about this, but also other types of CCI testing for different types of packaging, there's a wealth of information on the PTI USA website, so check that out as well. So Rob, thank you very much. Thank you all for what thank you very much. Thank you all for watching, and until next time, as always, stay well and stay safe. Bye-bye.
Okay, bye now. Thank you.